Okay, let's take a look at another example. The thicknesses of 12 pads designed for use in an aircraft engine mount are measured in millimeters. Okay, so let's say we had 12 different observations of these pads, and their thicknesses, the thickness of the pads, are measured in millimeters. Okay, and let's say that the target median thickness of these pads is 42 millimeters. Can we conclude that the median thickness differs from the target thickness of 42 millimeters? Okay, so let's set up the hypotheses. Okay, we just want to know, does the median differ from 42 millimeters? Okay, not bigger than per se, not smaller than per se, just differs from. Okay, is this thing different from 42 millimeters? Okay, so the equality statement would be strictly equality. Okay, tau equals 42. The median equals 42. Okay, so now we want to go and look at each one of these and calculate their differences. Okay, y sub I minus tau naught. Okay, how different is each one of these observations from 42? And we want to count up the negative values and the positive values of this calculation. Okay, or in other words, we want to look at how many of these observations lie below 42 and how many lie above. Okay, so here that lies below, below, above, below, below, and so on. Okay, so if we work this out, we should get 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lie below and 3 lie above. Okay, so S is going to be the max of 9 and 3, which is 9. Okay, because we have a two-tailed test. We want to pick the bigger of the ones that lie above and the ones that lie below. Okay, so S here is going to be 9. Okay, and our test statistic, really straightforward. How different is S from the expected value that we would expect S to be if tau naught really is 42? Okay, divided by 0.5 times the square root of n. Okay, so S here, 9, minus 0.5 times n, which is 12, divided by 0.5 times the square root of 12. Okay, and if we work that out, we should get 1.73. Okay, so our test statistic is 1.73. So we could go to a z distribution. Okay, go over here and plot 1.73, and we could do the p-value approach or the critical value approach. Let's just do the critical value approach just for the heck of it first. If we wanted the critical value approach, and let's say we wanted to draw conclusions with 95% confidence, that would mean alpha over 2 of 0.025 would be in the tail. We can go find this out, or we might remember that that critical value would be 1.96. Okay? So here, our test statistic lies in the non-rejection region. We would not reject the null and conclude that the mean is no different from 42. Okay, with 95% confidence. Okay, so now let's try the p-value approach. Okay, so we could draw out our distribution again. Okay, we could plot the test statistic directly. That's 1.73. Okay, the p-value would be this area multiplied by 2. Okay, because this is a two-tailed test. For a two-tailed test, we always take that area, multiply it by 2. So what is that area? Well, we can go look up in the back of the book or in the tables that we provide. We can go look up this area right here in a z table. Okay, between 0 and 1.73. That area is 0.4582. Okay, so that must mean this tail area, this area that we want, is 0.0418. Okay, that's just the area though. The p-value would be that area multiplied by 2. So the p-value here, p-value is 0.0418 multiplied by 2, which is 0.0836. Okay, so the p-value, 0.0836, that's a little iffy. Okay, so if you wanted 95% confidence, the p-value is greater than alpha of 0.05. So you would not reject the null. If you wanted 90% confidence, then you would be sufficiently convinced, p-value is smaller than alpha of 0.1, that you would reject the null. Okay? So it just depends on what level of alpha you want to use to draw the conclusion. You might choose to not reject the null or reject the null. Okay? Again, just depending on your level of alpha, because this is a level, this is a p-value that is, in most cases, someone would probably reject the null with a p-value less than 0.1. Okay? Just depends on what kind of conclusions you're probably ultimately wanting to draw. Okay? But this is a good illustration of how weak non-parametric tests are. Okay? So what are we seeing? We're seeing that there are 9 values that lie below this tau of 42. Okay? 9 out of 12 values lie on one side of tau than the other. Okay? That's 3/4 of the observations lie below tau naught. That would lead, most people to reasonably reject the null hypothesis and say, no, the median is really not 42. However, this is just a weak test. If we wanted to draw conclusions with 95% confidence, we would not reject the null. Even though 9 of those values, 3/4 of the values, lied on one side of tau, with 95% confidence, we would not reject the null and conclude that the median really is 42. So this is just a weak test. If you can assume normality, if we can assume that we can use a parametric method, we should do so. Okay? Because there are certain cases where you just have to be super ultra convinced to reject the null. And apparently 3/4 of the observations on one side of the median isn't super ultra convinced. In this case, if we wanted 95% confidence.